Hello, I'm Adam Dittbender with Interstates. I manage our E&I Services department. I wanted to talk about some of the E&I services that are used on a regular basis inside of a facility. E&I services can range from a small job on your instrumentation to a larger PM job on your electrical infrastructure or on your motors. Some of the common services I see out there are instrumentation calibrations where each device is pumped up or heated up, or flow is ran through a device on a periodic basis, and the results from that calibration are then documented in a sheet and then turned over to the facility in the end. That way the facility has a means to know that this device was calibrated on this date, it was working properly, it was accurate, or maybe on the other hand, this device needed replacement. Its electronics were fried, its calibration was off and unable to be adjusted. That's one of the E&I services that's out there. Another service that is commonly performed in the facilities, at least in the Midwest, is hazard monitoring audits. Hazard monitoring audits are necessary, especially in facilities that have dust. Facilities that have dust are typically facilities that are moving grain or processing grain, because in that process a lot of dust is created. And when dust concentration becomes too large, it can create a hazard. A hazard being as if there was a dust cloud and there was a hot piece of metal, an explosion could occur resulting in property damage, or even personal health circumstances as well. Hazard monitoring services helps to prevent those issues by checking bearing sensors, alignment sensors, speed sensors that are all installed on belt conveyors, grain legs, and other grain moving equipment, and monitoring for that hot equipment. If the equipment gets hot, if the bearing shells out and the bearing gets hot, the temperature sensor will let the plant know, let the operators in the control room know that that equipment is hot and attention needs to be paid to it. Having accurate periodic checks done on that monitoring equipment is essential to make sure that that hazard is mitigated. Some of the common E&I services that are also performed are heat trace audits. Heat trace is a device that keeps your pipes warm in the winter. It prevents your pipes from freezing up and busting, or just freezing up and your plant going down. Those circumstances can be avoided by checking your heat trace in the summer, maybe even in the fall, before the cold weather comes. Heat trace checks are best done by doing a MEG test to make sure that the heat trace is not shorting to ground, doing voltage and amp checks to make sure that the proper amount of electricity is flowing through the heat trace, and also doing capacitance checks as well to ensure that the heat trace is providing a reading that's accurate for how long the heat trace actually is installed on the pipe. Those are all periodic E&I services, just a few of the services that can be provided to help keep your plant running well. Another option is just having an embedded E&I crew on your site. Maybe it's a crew that comes in 1 or 2 days a week and has the knowledge to work on your systems and efficiently take care of your work orders for you, and then maybe they don't come back for another week. Or maybe it's having just a crew of E&I technicians on your site continuously that are always working away at the work order tasks and keeping the plant up and running and efficiently operating as well. Next, I want to talk to you about another service that can be provided, an E&I service, mainly instrumentation. This service is unique in the fact that it can actually fix issues inside of a plant without a person actually being at the plant. This is remote instrumentation support is what this is. And what this involves is remoting into the network of a facility, connecting through a Hart card inside of the PLC, and then ultimately connecting to a Hart device through that card and talking to that device and troubleshooting that device and configuring that device. The traditional method of doing that is to actually come on site, hook up a Hart communicator device, and perform all that work in front of the device. But this is now able to be done remotely with Hart instruments, which are very common. Hart-enabled I/O cards, which we'll show here in a little bit, and then simply a VPN connection to the plant as well. The value of this service is it allows for quicker troubleshooting, less mobilization costs, and no need to bring outside personnel into a plant. Next up, we'll show you two examples of remote instrumentation support. The first one will be by myself. I will show you how we do remote Hart instrumentation support, dialing in through a VPN connection to a PLC, through Hart communication to an instrument. And the second demonstration will be by Brett. He will show you how we can connect to a hazard monitoring system remotely via an Ethernet connection. Okay, now I'll show you a demonstration of remote Hart instrumentation support. Everything we need for it is right here on the table. We've got our laptop that we'll be using to connect to these instruments through this PLC rack. As you see, there's no wires connected, and the only means we have of connection to this equipment is via connection to the network connection that this PLC rack resides on. So from the instruments, we have our wires coming from the instruments back to the analog input card, which is in slot 3 here. Control Logic 1756 input card with Hart communication. That's important. It's got to be the Hart version of the card in order to pass through the signal from each of the devices into the control system. The control system is then connected via Ethernet cable back to our network. My laptop is then wirelessly connected to our laptop in order to communicate with the control system. If I was dialing into a plant's control system, I would need a VPN connection in order to get on their secure network. In this case, I don't, since I'm currently on the same connection. Once I'm online, I'll then use my software for communicating with that control system. I'm using Field Care to do this. There are other products out there that can be used in order to communicate, but I use Field Care for this. How we start out is we start out as the host PC, and then through through some steps, we'll make our way through this control system in order to get to the instrument and be able to configure it. All right, so now we are going through the internet, through my laptop, to our network, to our PLC that's on the network, through its backplane, to the card. We're nearly to the instrument now. I'm going to create network. It's asking me what Hart channels do we all want to scan on this card. We'll just scan them all. It should find 2 separate devices. There it is. It's pulling in information for device 1 of 2, and obviously our 2 devices are those. It takes a little while for the devices to pull in. Both these devices are just sending out a milliamp signal to input points on this card, and superimposed on that milliamp signal is a Hart signal. Hart is fairly robust. However, it takes a long time for it to transfer data, and that's why it's not instantaneous. It takes a little bit of time for all the information from each of these to pull into the card. All right, so it pulled up both of our devices. You'll see we have 2 devices here, LT demo and LEL demo. LT, level transmitter demo, and LEL, lower explosive limit demo. We will we'll first connect to the LT demo. Okay, we're connected. Now we'll go online. Online parameterized. Again, this will take a little bit of time for this information to load since it's all getting done over Hart communication. But as you see, it's slowly pulling in. We've got this little circle right here displaying status and that it's communicating. You'll see more and more of the information pull in here over time as it continues to pull it. Right now, this is the equivalent of of a technician actually being on site, on a job site, out in the field, connecting their Hart communicator to the device, hooking up their clips right directly to the leads coming out of it. However, obviously we're not doing that. We're able to do that very same function without being on the job site. All right, we are in. We can see all sorts of information for this device, even more information than we could see with a Hart communicator since we're using the software package. We can see the device type. This is an older type of radar, a Micropilot M. It's currently outputting 14.5 milliamps. That's 66% of its measured value of its scaling. We can see there's no present error on it. It's happy, it's green, there's no error conditions going on. We can see the tag number. If we wanted to change the basic setup of it and rescale it for the measuring range, we could go under basic setup. We could change things such as measured or tank shape, medium property, process condition, all fairly important conditions for setting up this device. And then finally we could also change the full and empty calibration, which essentially sets up the scaling of the device, when it puts out 4 milliamps, when it puts out 20 milliamps. There's a bunch of other options in here also for things we can change on this device to set it up for the process we're working on. We can also troubleshoot the device. That's one of the more valuable benefits of being able to do this is we can perform troubleshooting on a device with actually being on site. Let's say this device is putting out, it's telling the operators that the tank is 100% full, but we know it's only 50% full. We can perform troubleshooting. How we do that is we go into the echo curve profile. This is an option that only radar level transmitters have. It basically pulls in information as to the reflections that the radar is seeing in front of it. Here we have our data that is pulled in from the radar. We have a blue line and a red line. The blue line is our FAC, the red line is our envelope curve. That red line is what matters. You'll also notice a loading bar at the bottom. That's pulling in something separate. That'll be a black line called the map. We'll talk about that in a little bit. But for the red line always starts out high when it's a guided wave radar like it is with this device, and then it goes lower. And whenever you see a hump in the line, that means it's detecting an echo. So for our setup here, we're not installed in a tank pointing down at product. We are sitting on top of a table pointing up at a grid ceiling that's got a steel roof above it. And what we got here is we have this first echo at 6.2 feet from the device. So what that's basically seeing right now is the ceiling above it. If we were to tilt the radar, we would see the reading on the radar change. We would actually also see this red line change as well. We would have to re-pull in that echo to see that. But just to show you how this responds, I'm going to tilt the radar so that we can see a different reading. Right now we have 65.4% of our measured value. You'll notice it changed a little bit there. I have it on fast change. It actually detected the slight push I gave it as I pulled this out. We're going to turn this to aim at a different target. Right now it's aiming at the door behind me. We'll give it a little bit of time here to even out. And there it is. So you can see the actual level changed. It's now reading an echo from something closer to it than the ceiling is. The door is closer than the ceiling is, so our measured value increased. And you can also see that update here on the computer as well, on our connection as well, 74%, which is roughly what the display shows. The black line I was talking about before has now pulled in also. You can see that here. A lot of our troubleshooting is all done via the black line. You can't really change the red line. The red line always tells you what the radar is seeing. The black line allows you to tell the radar to ignore false disturbances. Let's say you had a red hump up toward the top here and your device was reading 90% full, but again your tank's only 50% full. We could manipulate this black line to map out that false echo toward the top of the tank. False echoes can be caused from any number of sources. Sometimes it's a level switch sticking in the top of the tank creating a small echo. Sometimes it's maybe some buildup on the nozzle that the radar level transmitter is installed in, and we just have to tell the radar, ignore that, that's not the right level, look further, go look further down in the vessel to actually track the proper reading. And that's what the black line allows us to do. One other thing I wanted to show on here is that documentation can also be printed out for the devices that are connected to. I'll demonstrate that next with the level transmitter. In the level transmitter, in order to print out documentation, we click on Create Documentation. We get this new menu screen that pops up and allows us to print a title page, cover page, device parameters. That's the main thing that we want to print, is the device parameters that tells you basically how the device is set up and everything you would need to know if you wanted to replace this device with a different one in the future. We'll save this as LT demo. A F for as found. Save. It'll give you a little warning message just saying that it's going to pull parameters during this time. Say OK. Here on the laptop we now have the sheet that the radar level transmitter printed out for us. We initiated this printing by clicking the print button. All of the parameters necessary for resetting up this device or for replacing it with a different device are all documented in this sheet. This sheet tells us everything we need to know about the device, including model number, serial number, tag number, order code for replacing it. The order code details what the process connection is, what the output is, what the hazardous area rating is, all sorts of information. As we scroll down, we can see the amount of mapping inside of it, the 4 to 20 milliamp scaling. Prints out the last previous error that it had. In this case, it had an error of W681 indicating current out of range. We can use that for troubleshooting the device when we connect into that device. If we know it had an issue in the past, that's a clue as to what the issue was that it was encountering. All sorts of other information is also contained in this document. Another very important piece of information is this echo curve that we looked at previously through field care. It takes a snapshot of that echo curve and puts it in this report so that we can see where that first echo was, whether that be the ceiling in the door or our case, or whether it be an actual tank level measurement in the plant. It also shows us our black line, which is our false echo suppression for mapping out signals as well. If we were to go back into the device and make changes, we would then print out another report with the as left information document that would then document any changes that were made to the device.
So here I have a CMC web server system. I have my laptop remotely connected into the Interstates network, and then here I have my various components of temperature sensors, FIB, bus converter, and a web server. The main component in this system is the CMC web server. This allows us to remote into the CMC system wirelessly and troubleshoot to a client basically from anywhere in the world, as long as I have an internet connection on my laptop and their network has an internet connection. So here is the CMC dashboard once you are actually remoted in, and here is an example of an elevator leg. I have the temperature sensors here giving me live temperature readings like you would see in the field. So this can really add benefit to the customer if they are having issues with their hazard monitoring system or have any questions. We can then remote into this system and either troubleshoot on the phone, determine whether if it's something that we can be done remotely or if we actually need to send someone to site. Now let's say your facility does not have Interstates integration currently on site. We can still remotely access this CMC system through this wireless router. Again, as long as this wireless router has internet connection and my laptop has internet connection, we will be able to remotely access the CMC system and troubleshoot it. So this gives the client added value if they're not currently Interstates or underneath Interstates integration, and we can still remotely access their plant. Again, this helps with troubleshooting, and again, this is usually critical safety devices at plants, so the upkeep and running of these is important to clients' facilities. By being able to access the CMC web server remotely, we can pull these reports at any time. So if there is a sensor that is causing the plant issues, or if the plant just wants to run monthly maintenance reports, we can go into this system, pull these up ourselves, and reveal any data to the customer that we may think that is alarming or needs any maintenance. So if you have a need for routine hazard monitoring maintenance and do not want to have an instrumentation tech physically come onto site every time, this solution can help with that, and we can maybe resolve issues remotely without physically being on site.
So we just showed you two examples of how remote instrumentation support works. I wanted to share an actual story with you of how it was used and applied in a facility here recently. We had one of our clients call us up recently, and they were having issues reading the right amount of level in one of their solvent storage tanks. The level was supposed to be 10%, and they were reading roughly 17%. This facility was a long ways away from any of our technicians, and the plant needed help immediately. So how we actually used instrumentation support to help this client is we remoted into their system. They gave us VPN access. We then connected into that instrument and was able to communicate with that instrument, obviously without being on site. In communicating with that instrument, we were able to pull up the echo curve for it, something I showed you in one of the demos earlier, and we were able to see what the issue was. We were able to see that the echo curve was locking on to a false echo, thus resulting in an erroneous reading, an improper, incorrect reading. So while we were connected to the device, we were simply able to perform false echo suppression, also known as mapping, on that false echo. And all of a sudden the device started working properly. It locked on to the proper echo in the tank, which was the liquid level in the tank. We had the client double check our work by putting more product in the tank and raising the level and taking some product out and making sure the level measurement went back down, and it worked like a gem, and their issue was solved. So I just wanted to share that example of how these can actually be applied to real-life situations and quickly and efficiently fix real-life issues for our clients. I hope you enjoyed our presentation today. If there's any E&I support needs you might have, please feel free to reach out to anyone at Interstates, including myself. These are services that we commonly provide to plants across the Midwest and even outside the Midwest.